Our final concept for solving logarithmic equations is also involving the natural log, but it is about what do you do when you only have one logarithm and not two, where you can use the rules for condensing. So the rule that we're going to look at today is when you are given an ln of a function is equal to a number. So in this case, you do not have more than one ln as you had before, so you're not going to do any expanding or condensing. You're going to solve this much like you did when you had a base e. Okay. Some things to note is that the expression that you have here as your x, you have a restriction. All right, and so again, your restriction is that your final answer cannot have x to be 0 or negative. So just the same as you had with regular logarithms. And so now what you're going to do is do order of operations to isolate the one ln on a side and your numbers on the other. And then now you're going to undo ln with using e. So you're going to take your e and you're going to raise both sides as the exponent. Right? And so in reality, what you're doing is you're using an old rule backwards. So there was a previous rule we had where we said if a to the x equals a to the y, then our exponents can be set equal to each other. And so now what you're going to do is you're going to treat this ln of x equals b like your exponents. You're going to say this left-hand side is going to be an exponent, and the right-hand side is going to be an exponent. And I'm going to put those as the powers to a specific base. And I'm choosing specifically to use base e because of how e and ln undo each other. So now again, just like it worked before, when I have e raised to the ln, these two cancel each other out, and it drops down my exponent. And then in my calculator, I can figure out what e to that power is. So you're going to have to use your e to the x button to round. And so for all of these, we're going to round to 4 decimals. All right. That was the standard we used before, so we're going to continue that. All right. Unless something tells you to do something different. You know, if it says round to the nearest hundredth, then you'll just do that. But let's do 4 decimals for now. All right, so we have a couple of examples. All right, so example number 1. This is going to be starting off with -3 ln of x equals 10. And so now I need to get rid of this -3 that's being attached to my ln. And so again, I'm going to divide both sides by -3. All right, and again, this is not the only way to do it, but it's the way I'm going to show you for now. All right, and that cancels out. All right, and so then I have the ln of x equals -10/3. All right, this must stay as an exact value. All right, meaning that it can be written as a decimal if it terminates, but you cannot turn this into a decimal and use an approximation. You must leave it alone. And so now, when I raise both of these as my exponents on e, I'm going to get that x equals e to the -10/3. And again, that's my exact value. But I want to approximate that to 4 decimals. And so this is where you'll need your calculator. All right. And so again, I need my e to the -10/3. And this is going to be approximately 0.0357. Right? So again, here's your process, and you can see that it's much like the rule I gave you. Right? And so we're going to do another one just to kind of get this under our belt before we change speeds here. All right, so our example 2, this is going to be 5 plus 2 times the ln of x equals 4. Okay. And so again, now I need to isolate the ln of x, which means I need to subtract 5 from both sides first. And I'm going to get 2 ln of x equals -1. And then when I divide by 2, I get the ln of x equals -1/2. Right. Right, now I'm going to raise those as the exponents on my e. And so I get x equals e to the -1/2. Right? And so let's approximate that. And here, because negative 1/2 is the same thing as negative 0.5, I can do that. And so 0.6065. Right? So that's going to be your general process. You're going to do this a few times. But again, it's just using ln and e together. So we've got one more idea that we need to work with in terms of ln's and e's and exponential functions. And so what we want to do is we want to look at a general model. All right. I mean, this is kind of a model. It's also like a rule, but we want to just go through the general idea. So what you're going to see is you're going to see something that is the general form of a base to the 2x minus some number, all right, times that same base to the x. It could be a plus or minus, so let's just do plus. Plus a constant. Right? And what you are going to need to recognize is that this is the model of a quadratic. All right? In a quadratic, you have a base that's being squared, a base that's the first power, and a constant. And you have coefficients in here. And so this is the same general model as when I had a base squared, all right, plus a base, or a number times the base to the first power plus a constant. But you want to just recognize that your base now is not the variable. Your base is a number. Right? So say, for example, I had something that looked like this. Right? So let's just do an example. So I have e to the 2x minus 3e to the x plus 2 equals 0. And what I need to recognize here is that my base is an e to the x power. So really, I want you to focus on the one in the middle to see what is my base to the first power. All right? That means that this is the base to a second power. And so again, this is a model where I have a base squared minus 3 times the base plus 2 equals 0. And so I have to think about how would I factor this and start solving. All right? So I would factor this where both would get that base. And then I'd be looking at the product of 2 adds up to be negative 3. And so I would use negative 1 and negative 2. And then I would keep solving. So that's the general idea of what you're going to do when you have a base that is something other than the variable. So this is going to have the same exact model. But instead, we're going to say our e to the x is our base. All right? You're still looking at the product of two numbers that multiply to be a positive 2 and sum up to be a negative 3. So the coefficients in front, those are the ones we still use for product and sum. And so this is going to be negative 1 and negative 2. And now when you use the zero product property, that means that e to the x equals 1 or e to the x equals 2. All right, so when we do this, now what we've done is we've set up an exponential function, all right, that we have to solve. And you have to go back to previous notes of how ln and e work together, because you're going to take the ln of both sides. All right? And again, ln and e cancel out. So one of your answers is going to be the ln of 1, which in this case is 0. Or you have the ln of e to the x equals the ln of 2. And I have to figure out what the ln of this is. Now we can leave it exactly like that if I want exact answers. Or I'd have to say that x equals 0 and check. The ln of 2 is about 0.6931. So that would be my general idea. And so these are a little tough because you have to do a little bit of extra work to try to think about what the model looks like. All right? And so again, I want you to recognize that whatever this middle term is, that's going to be the base. Think about whatever this one is, all right, because the first term says I have 2 of them. Just write this in both. And then look at how you're going to break up your products and your sums. All right? So one more like that, because I think that's difficult. All right? So I'm going to write 5 to the 2x plus 5 to the x minus 6 equals 0. All right, so again, I'm going to look at this first one right here. All right, and that's going to be what I'm going to put in both as the first term, because again, this really means I have two of them. And so this model right here is the same thing as if I wrote something squared plus the base minus 6 equals 0. All right, so there's really like a 1 coefficient in front here. And so however I would factor this is how I would factor this. So I'm looking for the product of two numbers to give me negative 6. All right, and then I want the sum to be a positive 1. All right, and so these have to be opposite signs. All right, and I'm going to use 3 and 2. So now what you have to do is you have to set this up. 5x equals negative 3, or 5 to the x equals positive 2. And again, old exponential function notes mean that this is going to be the same thing as the ln of 5 to the x equals ln of negative 3. Right? And this is going to be a problem. All right? You can check it in your calculator that if you take the ln of a negative number, you're going to get an error. So since you can never have a negative number next to ln, I'm not even going to bother with that answer anymore. All right? So if you get an error in your calculator, it means that you're trying to input something that doesn't work. All right? So I'm going to move over here to this side into the ln of 5 to the x equals the ln of 2. All right? All right, so x times the ln of 5 equals the ln of 2. I'm going to kind of shift this over here real quick. All right. So in my calculator, I need to approximate this. All right. So then the ln of 2 divided by the ln of 5. And that's going to be about 0.4307. So I know these are tough. You're going to have a few that you're going to need to practice, though.